Welcome back, reinforcement learning. This session I explain distributed training. Okay, distributed training concept. We are using distributed training in machine learning and deep learning. We are mainly using deep learning to compute the data in distributed training. We are also using distributed training in reinforcement learning, especially in the distributed advantage actor critic model. Distributed advantage actor critic model using distributed training. Okay, this is the distributed advantage actor critic model. It is a combination of actor critic model. Actor critic already explained the previous session. Actor critic is the combination of policy and value function. Actor function is the policy function. Critic is the value function. We are using advantage function to evaluate the selected action and in order to specify the reward. And distributed, here training is distributed, that's why it is called a distributed advantage actor critic model is a specific implementation that combines the advantage of actor critic methods with distributed training. Okay, generally we are using the batch training in deep learning. Okay, in the batch training, the set of samples we are using to training in the deep learning in order to reduce the variance of the variance in gradient values. So here reinforcement learning experience replay, we are using the Q learning concept. In Q learning, we are using the experience replays to store the past data we stored in experience replay buffer. The experience replay buffer is the sensitive in memory. Okay, it requires a lot of memory, so that's the problem in complex environment problems. So that's the problem in the value function. It is in Markov property means the decision is depend on current state. So it needs the previous data. We are using in deep learning RNN, recurrent neural networks concept. We are using it is it stores the sequence of previous data. Okay, experience replay requires the more memory to store the previous data. That's the problem in Q learning and the value functions. Here we are using parallel agents and environment. The agents are trained parallelly with the samples of the instances of the environments. That is a distributed training. The agents are trained parallelly on instances of the environments is called a distributed training. We are using the distributed training. It is solve the problem of the experience replay. It's not required to store the previous data. They are executed instantaneously, parallel. They are executed simultaneously. So it is not required the previous data. So experience replay is not required when we are using actor critic method. The combination of both value and policy functions with the distributed training, it is not required the experience replay to store the previous data. Why? They are executed simultaneously. The agents, all agents or sample agents are executed instantly with the instant environments. So it's not required the experience replay. Here the batch learning, the set of samples on model is the batch predictions. It give the aggregate gradient value. Here the independent experience, this is the one sample. They are distributed model. Okay, the models are executed parallelly. Okay, all are executed instantly. So they are give the finally we calculate the aggregates of the all sample gradient values. So it is reduce the variance, the aggregate gradient of the all model training. After training, we calculate the aggregate gradients. So it's solve the variance of the gradients. Here we are using the distributed training. We are using multi-processing and multi-threading concepts. In multi-processing is a true parallelism. Okay, computers are handled on different CPU cores. In multi-threading is not a complete parallelism, but Here, see the samples, the multiprocessing, they are executed in the different memories, and multi-threading, they are all threads. Okay, the number of threads are share the same memories. So multiprocessing are executed their different memories, but multi-threading, they are all are using same memories. So it is multi-threading is a switching between the task. Multi-threading is the switching between tasks. Multiprocessing is executed parallelly. So in the multi-threading and multiprocessing concepts, we are using in distributed training to train the agents. So in Python implementation, we are using multiprocessing library. Multiprocessing library we are using to distributed training of the agents. Here Python distributed reinforcement learning computations across several processes. Each process independently compute the gradients based on its observation. The gradients are aggregated to update the model's parameters. So it reduces the variance of the gradients. So benefits of distributed training, it eliminates the replay buffer. It's completely eliminate the replay buffer. It's not required the all are executed parallelly, all are executed instantly, simultaneously. So it's not required the previous data. So it completely eliminate the replay buffer. And low variance, aggregating gradients across the agents for the low variance gradient estimates. So it low variance gradient. Efficiency, distributed computing executed multiple cores accelerate the learning. So it increase the learning. So it improve the efficiency of the model. These are the benefits: eliminate the replay buffer, low variance gradients, and efficiency of the model. So distributed training in distributed advantage actor critic combines the both advantages of the actor critic model and distributed training to solve the complex problems in reinforcement learning. Thank you.